Hey guys, Danielle here to teach you about Module 4. We are going to be learning about transformations, symmetries, and tilings. All right, so right here, this first picture on the left, we'll call that picture 1 and picture 2. So on picture 1, Ephraim and Devontae were asked to reflect the pattern block figure shown on the left over the horizontal line. Now, horizontal line, of course, is going to be right here. Okay. Through the center of the square. So we're putting it through the center of the square. They've rearranged the blocks to form the figure on the right here. And so what type of rigid motion did they use? Did they use the correct one? And the answer is no. So figure 1 is not correct. They basically did a 180-degree rotation. If you were to turn this, it will turn 180 degrees to form this figure right here. What they wanted to do was flip it over a horizontal line across the square right here. And on figure 2, I've shown you what it would look like if they were to flip it over a horizontal line. Now say if you were to completely do a mirror image, it would be this one right here. So they did not do it correctly, but they did do a 180-degree rotation. All right, so right here are some shapes given. We are going to determine if they show reflection symmetry. So again, symmetry. Simply just a mirror form. So if we were to look at this one, if we were to cut it down here, or here, or even somehow here, it wouldn't create a mirror image. So this one is a big no. But here we have the diamond. Everybody knows if you have a piece of paper in the shape of a diamond, you can cut it in half this way and have the same look on both sides. You can cut it this way, and even this way, and this way. So those are all create symmetry. This shape is similar to the first one. It is not symmetrical. In the triangle, you can cut in half and half again, because all of these sides are the same. And again. So just basically at each vertex on that triangle. So then we have a half circle. Well, we know that a circle is symmetrical. If we had a regular circle, it would be symmetrical this way and this way. Well, we have half of it. So it is symmetrical this way. Now we have a square, or a rectangle, I'm sorry. So rectangle, we all know is symmetrical. You can cut it in half this way, cut it horizontally in half, and then one vertex to another and one vertex to another. So, and then we have this triangle, and these two sides are the same. This one's different. So it won't be like this triangle over here. However, you can cut it in half. Now the shape. You can cut it in half this way, one vertex to another, one vertex to another, and again. So that's how you do those. Mira cut out a regular pentagon a hexagon, and an octagon, seems that her form is a vertex figure. Let's determine that. So, to figure out a vertex figure, vertex figure is multiple polygons put together, and we are counting up. So say you have this octagon right here. Well, we all know that a octagon has 8 sides. The hexagon has 6 sides, and the pentagon has 5 sides. So, what you do is find out, by using the formulas, how many each interior angles are. So, of course, these are all regular shapes. So, they're all going to be the same for each one. So, if we had an octagon with 8 sides, that is going to be an interior of 135 degrees each. This will be 135 degrees, so this one, and so on. This hexagon is going to be 120 interior angles. And pentagon, 5 sides, regular pentagon, has 108 degree interior angles. So, what you'll do is add 135 degrees plus 120 degrees plus 108 degrees, and you're going to get a total of 363 degrees. So, our vertex figure equals 363 degrees. So, there's going to be quite a bit, or just a little bit of overlapping. So, what you'll do is have to find a different shape if you were to find a vertex figure. But this is not a vertex figure. Your vertex figures have to equal, and your vertex figure have to equal 360 degrees exact. No less, no more. Right here, we are going to demonstrate why triangle QPT so we have triangle QPT, and then we also have triangle SPT. So they look the same, but let's make sure. So SP and QP line are both the same size. QT and ST are the same size. We have these lines to ensure that it is perpendicular, and as well, and this is a straight line. So, and this is obviously the same line. So these are the same. This is true. Now, are the angles QPT, this angle right here, and SPT, this angle right here, the same? Well, the triangles are the same, and they both have the P in the middle and the T at the end. So the way the triangles are set up, they are the same. What is triangle QPV, QPV, and SPV? So again, same sides right here. This is the same side, of course. And then these, they both touch vertically on the circle. So yes, they have the same sides and same angles, which make the triangles the same. Now, QVP angle, QVP. So this angle right here, is it a right angle? Well, line PT and line M, or QS, however you want to say it, call it line M because that M's right there. These are perpendicular lines. Perpendicular is at least two lines crossing each other that form 90-degree angles, or as we call a right angle. So yes, that is true. Let's go on to the next one. Oops. All right, so we have this shape right here, a regular pentagon, penta, and then an equilateral triangle right here, equilateral, and P is the common vertex. And why is it a common vertex? A common vertex is where the circle, the penta, and equilateral triangle all meet together. So that's our common vertex. And our center is O. It is the center of the pentagon, center of the equilateral triangle, and the center of the circle. So triangle PQR is the equilateral triangle. And if you look at angle POQ, this angle right here, it is 120 degrees. Okay. And then we have, this is angle POQ, sorry. And then we have angle PON right here. Just a little bit bigger. It's going to be 144 degrees. So if we do angle NOQ, this is what we're trying to find. We take, so hold on. We're trying to find angle NOQ right here. This angle right here, this little angle. So we found out angle PON. And we found out angle POQ. So to find angle NOQ, we're just going to subtract angle POQ from PON. Simply just because, you know, this is the whole angle right here, and we don't need this to find NOQ. So we're going to take 144 degrees minus 120 degrees, and that's going to equal 25 degrees. So angle in OQ is 24 degrees. Okay. All right. We need to find the height of the cliff. By holding a ruler 2 feet, okay, so I put this in a little triangle down here to help y'all out. 2 feet. This is the angle of the ruler from her eyes, distance from her eyes to the ruler. Right here. So by holding ruler 2 feet in front of her eyes, as illustrated in the diagram, Jenny sees that the top and bottom points of vertical cliff face line up with marks separated by 1.5 feet or inches on the ruler. Jenny is about 1/4 mile from the cliff. What is the approximate height of the cliff? So again, we're trying to find the height of the cliff. But I've already put it in a triangle. This is height right here. This is what we're trying to find. How will we find that? Well, there's a formula here. Distance from her eyes to the ruler over distance between the ruler markings equal her distance from the cliff over height of the cliff. Well, we all know that we're trying to find height of the cliff. So we're going to rewrite this formula. Now I'll just point out that angle ABC right here, this angle is equal to APQ ACB right here is equal to AQP, and BAC right here is equal to PAQ. So those are obviously the same. So with that being said, right here, this top one is a corresponding angle, and so is this one. And this right here is the same angle like we just determined. So these are corresponding. These two. This is the same angle. So now we're going to rewrite that formula. Let me click here one more time. So you can see that this triangle falls along with the cliff. All right, so in order to rewrite this formula, we're going to write height of the cliff over 1/4 mile equals 1.5 inches and 2 feet. Now, we have the height of the cliff because we're trying to find it. 1/4 mile is 1,320 feet. And then we still have the 2 feet. Now we had 1.5 inches, but we need to make sure that these are all in feet because this is in feet and this is in feet. So we need to make the 1.5 inches into feet. So it's going to be 0.125 feet. Now, height of cliff, converting all that, is going to be 0.125 feet. Make sure put in your measurements. 1,320 feet divided by, all of that divided by 2. So your height of your cliff equals 82.5 feet. So right here is 82.5 feet. All right. And that's it. Thank you all for learning Module 4 with me. Really appreciate y'all watching.